So hey everyone, let's discuss today's lead code now. So this is the first question. In this, we were given a array of numbers. Let's say, let's represent it as n1, n2, n3, n4, n5, and m. Let's say there are m numbers in total. Now we need to choose three numbers such that a plus b minus c is maximized. Hello. Seems everything is fine. Okay, so we need to choose A, B, and C such that A plus B minus C is maximized. So A, what should our aim be? A should be as large as possible. A and B should be okay. So A and B should be as large as possible, while C should be as small as possible. Okay, so why this thing? Because A and B adds up to our sum, let's say, while C is subtracted from our sum. So what we would want, that subtracted thing should be as small as possible and the added thing should be as large as possible. Okay, so that's why it's good to choose the smallest number of array as C and the largest two numbers as A and B. All right. So for that reason, what to do to get the largest? 2 in the smallest numbers. All right, so what to do to get the largest two numbers of an array and the smallest number? Sort it for sure. And what to return? The largest sum of largest two numbers. What are the largest two numbers? Number at last index, number at second last index, and subtract the smallest number. That is it. Let's move to the next question. Okay, for this, we are given a string consisting only of characters A and B. You are allowed to repeatedly remove any substring where number of A characters is equal to number of B characters. After each removal, the remaining part of the strings are concatenated together without gaps. Return the integer denoting the minimum possible length of string after performing any number of such operations. The substring is a contiguous non-empty sequence of characters within a string. Okay, so what the question says that we are given a string consisting of only A, B, and we can remove any substring where the number of A's equal to number of B's. For example, substring 1 to 4. It consists of uh, two A's and two B's, so we can remove it. Similarly, from 2 to 5, it contains of two A's and two B's, so we can remove it. Now we are asked what is the minimum length of string that is possible after performing such operations. Now let's understand. Okay, let's say the count of A is 5 and count of B is 3. Now, what are the, okay, let's understand with smaller examples. Let's say count of A is 2 and B is 1. What are the possible strings? These are the possible strings. And what is the possible answer? It is A in all the cases. Let's understand how. In the first test case, remove substring 2 to 3. This A to B. Okay, let's understand it. Okay, let's say we had A, B, and two A's and one B. Then what are the possible strings that can be made? These are the possible strings. And what can be the minimum answer? You remove this substring and only one A is remained. Remove this substring and only one A is removed. Remove this substring, starting one, and only one A is remained. So what is our intuition through this approach? Maybe we can remove all the characters occurrence, smaller character. Maybe now let's try to prove this because that's what the smaller test case suggests. Okay, let's say we had uh, some A's and B's in this portion and 2A extra and some uh, A's and B's in this portion. Okay, now here, how do the number of A's increase? Okay, sorry for inconvenience. Like let's say we had two extra A's in. Okay, so we say that the count of A is equal to count of B plus so the count of A equals to count of B plus 2. Let's say. Okay, so what do these mean? This means that there are some A's and B's that are balanced in the right portion of then then some A's and B's that are balanced in this portion. Maybe they are zero. that is this particular string is 0. That is, it does not contain any A's or B's. Then again a A, and then A B A B. So what do we see? That here this A is extra and this A is extra. Rest, all the A's and B's can be combined with each other such that the number of A's and B's in that substring are equal. So these substrings can be removed because that's what our operation says. So in the other scenario, what we are assuming? We assume that number of B's is equal to 2 plus number of A's. So how can we represent this? That in the starting portion, there are some A's and B's which are balanced among themselves. Okay, some A's and B's balanced among themselves. Then a B because two B's are extra. Then again a AB string which is again balanced among itself, and then again a B, then again some A's and B's that are balanced among themselves. The string can be represented like this. Am I correct? And uh, this particular substrings which are balanced among themselves can be removed with the operation. So the remaining number of elements is equal to the number of extra B's, or if A is extra, then the remaining number of elements is equal to number of extra A's. So this is the proof for our logic. Although the logic was pretty intuitive and can be proved using this method. Okay, let's write down the code. What do we need to find? We need to find the abstract value of occurrence of A minus occurrence of B. Am I correct? So let's iterate over the string. If it's A, then ct plus plus, else ct minus minus. At the end, return abstract value. Okay. This is the next question. We'll do it again. Okay. You are given a positive integer n. For each integer x from 1 to n, write down the integer obtained by removing all zeros from the decimal representation of x. Okay, what do the question mean? Like, let's say we have n as 10. Then write down all the numbers from 1 to 10. Then uh, remove zeros from all the numbers that are consisting some zeros. Like, let's say we are given n as 10. Then every element that consists one or more zeros, remove all the zeros from those elements. In this 10, remove 0, so it becomes 1. Now remove the duplicate elements. This one and this one matches, so remove this. Now return the length of remaining numbers, or the count of remaining numbers. Okay, since there are 9 numbers, So the answer here is 9. So what do we get to understand? What are the numbers that contain zeros? Where can 0 be present? 0 can either be present in middle of number or in the end of number. Okay, these are the zeros present in middle and these are the zeros present in end. And any particular zero would lead to a smaller number. Removal of zero would lead to a smaller number, which was already present smaller than the current number. Okay, and what are the possible domain of our search? Domain consists of all the digits from 1 to 9. Okay, because if there is any zero, then it will be removed. So what the question transforms to? Question transforms to find the number of unique numbers smaller than n and do not contain 0. Okay, why this transformation? Because if we remove zeros from a number, it transforms to a smaller number, which is unique and does not contain 0. After removing a number, the number of digits decreases. Okay, after removing these zeros, the number of digits decreases. So it transforms to a smaller number. How to solve this question? Find the number of unique numbers smaller than n and does not contain 0. Okay, so let's say we had 1342 as our uh, required given number. Okay, so every numbers that have lesser than 5 digit and is made of 0 to 9. Okay, closed 0 to 9, sorry, not 0 to 9, actually 1 to 9 is a possible value. Am I correct? And what about 6 digit? 6 digit, every number that starts with 1 and let's say the second digit is 1, then here we can insert any numbers in these three places. Okay, now let's say it starts with 2. We can insert any number in these three places. Similarly, if we start with 3, we can insert any 3 digits here. Now, if we start with 4, there is again some constraint. That is, if this particular thing is 1, that is the third digit is 1, then the second two numbers can be anything. If the second digit is 2, then the last two numbers can be anything. If the third number is 3, then there is again some constraint in these two portions. That is, if this digit is 1, this can be anything. And if this digit is 2, then this is restricted to be only 1. Okay, so how do our restriction starts? If our current uh, number is 5 digit, what is our algorithm? Okay, our observation was all numbers smaller than n and contains only okay. This is how our problem transforms. And what do our algorithm says? It says if count the number of digits for numbers with digit, let's say this is D, smaller than D, all possible accepted for number with digit equal to D. Fix the current start from the largest position. Fix the current position. Calculate answer accordingly. Okay, so these two portions are now pretty much clear. Now understand how to fix the current position and calculate the answer. Okay. If at the current position we choose, if at the current position we choose a digit smaller than present digit, choose any digit for remaining. Okay. If at current position we choose a digit equal present digit, continue the process. We continue the process. Okay, now let's write this down in the form of algorithm. First of all, calculating the for calculating the smaller digits, let's store this before. At max, how many digits can be there? 15 digits. Okay. Now let's convert our number to string. This is the function for it. Okay, so our answer denotes our final number of values smaller than the current number, and for all the digits smaller than the digit of our number, that is our digit of number is equal to n counted by the size of string. Now for L minus 1 to 1, that is all the numbers having digits smaller than the given number, we add all the possible numbers according to our algorithm. Lesser than 5 digit and is made of 1 to 9. So 1 to 9, how many numbers are there? 9 numbers. So for each places we can insert 9 digits. So 9 to the power I is the number of ways. We keep on adding that. What is our current order? Let's say current place value. It is L minus I. If our current digit is not equal to 0, then answer will be equal to what are the smaller values that are present. That is, we did not choose the current digit, rather choose smaller values. And what if we the current digit is equal to 0? Then there cannot be any smaller number possible. So break from here. So this is our uh, discussion for LeetCode for today. Let's meet.